Math 1314, Tyler Junior College, Section 4.5, Exponential Growth and Decay. Comment about modeling. I'll tell you up front, there's no new math I'm going to teach you in this section, but I do want to kind of comment about what we've done versus what's actually done in modeling. What we've done is taken very little evidence to create a function. For example, the function that we made in the second video to model the growth of world population. But it's kind of naive and almost arrogant to assume that we can predict so much based on so little information. So how is this really done? This is talked about more in statistics and calculus classes, but I think the idea is understandable at this level of mathematics. The way modeling is really done is you gather a lot of data. Now what you see up here is not a lot of data. This is 8 points. This is, I don't know, that's not very many either. When I say a lot of data, I usually mean dozens, if not hundreds, if not thousands of points that you can put on a graph. Then you start looking for trends. Now I didn't want to put hundreds of points, so let's just say that we got some points up here. This seems to be in a linear trend. These kind of seem to be in a line. Now clearly they're not in a straight line, but they're fairly linear. So how do we come up with a model, for example, an equation of a line that doesn't even hit all the points? Well, the answer is we come up with what's called the line of best fit. Without getting into too much detail, we're looking for a line that if we were to measure how far off the line each point was and squared those distances, there's a reason it's squared, we're looking for the line that minimizes the sum of those squared differences. These distances are called residuals, if you are, how far off the line of best fit we are. It takes some calculus to develop the technique for finding the unique line that minimizes the squared residuals, but it can happen. And the same thing for other different shapes. For example, if we gather a lot of data and it looks like an exponential function, then we can find the one that comes closest to all the points, in the sense that if we measured all the residuals and squared those distances, we can minimize that sum. A logistic model, by the way, we didn't actually sketch one, but a logistic model starts off exponential, but then it slows its growth rate and actually has two horizontal asymptotes. The top one is representing the limiting population, the bottom one is usually representing 0. But again, there are techniques for saying, okay, this has the correct shape, it's not perfect, but the theory is let's find the shape that minimizes the sum of the squares of the residuals. And that's really how modeling goes. It's not, I've got two pieces of information I can now accurately predict the future. By the way, you can never accurately predict the future when it comes to modeling. You can only have a good model and try to refine it as you get more information. If you're really interested in modeling, I recommend taking some statistics classes, and I actually recommend taking some calculus classes to understand the theory behind how you come up with the line that comes closest to a set of given points, or the exponential growth, or the logistic.